Hello guys, this is Sri. So today we are going to see about the GTID and this is a kind of comparison session between MySQL and MariaDB. So we will see this in detail like how this GTID is implemented in MySQL and MariaDB and what is the difference in the structure and how they are getting updated while writing the transaction and while purging the binary logs and how to set up the replication on both MariaDB and MySQL. And also there are few parameters we will try to understand mm, like how it is designed in the MariaDB and how it is designed in the MySQL. And also we will see that skip slave counter is not worked in MySQL when you use the GTID replication, but it will work in MariaDB. So we will see that as well. We will create the replication error and we will see how to fix it. So I would say this is the part one video because there are a lot of other things also needs to be addressed uh, with this comparison, like the difference in GTID implementation in MySQL and MariaDB. So we already have one video related to GTID, I think, in our channel. So I think there we cover some basics of the GTID. You can go through it in case you want to understand. Yeah, that is specifically for MySQL. Okay, so a quick overview like why we need the GTID, right? So may aware like GTID is used to uniquely identify the transaction across the multiple servers. Let's say if you have one source and different more than one replicas. Uh, let's say if you are writing some transaction on the master, you may have, I mean, it will be replicated to the replica, right? Let's say you have you want to switch the replica to the other master. You want to switch the primary. In that kind of situation, that bin log position may be different bit across the server. So you need to find the relevant bin log position based on the transaction ID, the XID. Then you need to run the change master command on that. Here you need to spend some time to identify the equivalent position on the different server, right? But using the GTID, it is not needed. All the transactions will be identified with the unique identifier. So switching those primaries, these things will be easier comparing to the bin log based replication. Okay, so I would call it that is the main advantages of having the GTID replication. Fine. So you can also see that recent replica set, InnoDB replica set, and group replication, InnoDB cluster. For all the setups, we need the GTID. It is mandatory, right? Because there we are keep searching the primaries and the group replication. InnoDB cluster provide the synchronous replication, right? And mainly that replica set, InnoDB replica set, GTID is mandatory, so that you can easily switch the primaries, right? Fine. So let's coming to the topic, MySQL and MariaDB. Yeah, so GTID is introduced in MySQL 5.6. For MariaDB, it is introduced in 10.0. Okay, and the structure itself, it is different comparing to MySQL and MariaDB. For MySQL, the GTD structure will be the UUID and the transaction number or transaction ID. Okay, so the UUID server UUID colon transaction number. And for MariaDB, it is different. There you need to configure the another one ID, which is GTID domain ID, and it is hyphen server ID and hyphen sequence number. Okay, so yeah, that is kind of a transaction number. So there in the MySQL we have only UUID colon transaction ID. For MariaDB, we have domain ID hyphen server ID hyphen transaction ID. Okay, and the our parameters which needs to be enabled the GTID is GTID mode and enforce GTID consistency. These two needed in MySQL. In MariaDB, we need to configure the GTID domain ID. Okay, so this number will be available here. I will show you. So GTID domain ID, we need to set it up, and also GTID strict mode. Okay, so here this enforce GTID consistency from MySQL and GTID strict mode from MariaDB. Both are more or less it is equivalent. Okay, so it will to enforce the to make sure your GTID is consistency and it all the transactions which are executed or GTID it is not violating the GTID consistency. Okay, that will be make sure by these parameters. For example, create temporary table, drop temporary table, and create table with the select statement. So these statements are unsafe for the GTID to GTID consistency. They may violate the GTID consistency. Okay, so to ensure that we need to enable this parameter GTID enforce GTID consistency on MySQL and GTID strict mode on the MariaDB. So from MySQL we have different values like you need to set it on, off, and I think one more value is warning. Okay, so yeah, fine. Let's skip it. I have the plan to make the another video to see how this enforce GTID consistency work with a different statement. So we will cover that topic more deep on that video. Okay, fine. Now, yeah, let's try to understand how these parameters, how to enable the GTID, all these things we are going to see in the demo. So I have created 4 servers overall. So you can see these two from the left hand side, which are the green color. The above one is the source, and the below one is the replica. And here in the second session, you will see this pink color terminal. The above one is the source, and below one is the replica. So here you can see this uh, green color terminals or MySQL 8.0.40 version. You can see MySQL 4.0, 8.0.40, and here also 8.0.40. And if you see the pink color terminal, this is the MariaDB. Okay. So here this is the version is 10.3.39, and another server is also have the same version 10.3.39. So first we will enable the GTID, then we will see how this GTID structure. Then we will write some transactions. Then we will see how this GTID is getting changed, how it is incrementing. We will try to understand these things first. Then between MySQL and MariaDB, both side, and then we will set up the replication I mean the GTID replication for MySQL and MariaDB, and we will see what is the difference there. Then we will create the replication error, and we will see that slave skip counter how it is behaving in both MySQL and MariaDB. That is the motivation for this part one session, and there are more I will try to cover in the next part. Okay, so currently, if you see show variables like uh, GTID. You can see currently the GTID mode is off here, here also off. So this is by default, it is off, and here also you can see the GTID domain ID is 0 and the GTID strict mode is off. The same thing. So this is by default, GTID is not enabled on both MySQL and MariaDB. So we need to make it enable. Okay. So as I mentioned, we have the parameters, which is like here GTID domain ID for MariaDB and GTID strict mode and GTID mode and enforce GTID consistency. These parameters we can enable dynamically also. You can use the set global or set persist. You can enable it. Um, so here what we are going to do, we are going to make these changes in the config file, my.cnf file, and we are going to restart the MySQL service because we need to add the other parameters like server ID, the basic replication requirement. The server ID, all these things needs to be enabled. So we will enable all the parameters in the my.cnf, then we will do the restart. Okay. And also we also need to enable the binary logs on the MariaDB. For example, let me check. Yeah. So in the MySQL 8, binary logs are enabled by default. So you can skip that. But in MariaDB, binary log is not enabled by default. You are not using the binary logging, right? So we need to enable the binary logs also for the MariaDB servers. Okay, fine. So let's try to do that. Let me open the thing. For example, 1 second. Yeah, so yeah, sorry for that delay. Now let me open the config on the MySQL side. For example, I'm unmute, right? etc MySQL. So this is the Ubuntu machine. So the default configuration location is slash under the slash etc MySQL, and we have the include directory config in the my.cnf. Okay, so here let's enable. First of all, let me enable the server ID equal to 100 and login equal to MySQL source. Yeah, you can give any name for the login. So it will take that as a prefix for your binary log name. Okay. So for in our case, binary log will be created MySQL source dot 00001, like that. Okay, then GTID mode equal to on. As I mentioned, you can also enable this in using set global command. You need to go in the stepwise, like off permissive, on permissive, then finally on. Okay, so yeah, that each stage have the different thing that I will also try to cover in the next session. I think I remember I already covered. I'm not sure. Let me check in my previous video. If it is not covered, then I will try to cover in the next session. Okay. And enforce GTID consistency equal to on. Okay. So this GTID mode and the enforce GTID consistency is for GTID, and server ID. It should be unique. We are going to configure the replication, right? So it should be different for master and slave. So here I given 100, I will give the different number there. Fine. Let me copy this and log slave updates. That is fine. And that is also enabled by default in the MySQL 8. Now service MySQL restart. Okay. Let it restart. And let me do the same changes on the slave replica as well. MySQL d.cnf. So this is the default location of the CNF. There we have all the MySQL D parameters. And in Ubuntu, you can use the slash etc MySQL slash my.cnf. Okay. So there we might have the include directory config. So we are updating here. That's it. So you can, if you, yeah, you can also make just one config for everything, just like a slash etc slash MySQL slash my.cnf. You can edit over there. And here let me update 101. Server ID is 101. And the login, let me change to replica. And GTD mode is on. Enforce GTD consistency, it is also on. Fine. Now, let me restart the MySQL service. So whenever you made the changes in the config file, you need to restart the MySQL service to take that effect. Okay, fine. Now coming to the MariaDB side, let's etc MySQL here, MariaDB conf.d, the default location, and the server config file name is server.cnf. So here under you can see this MySQL D group, right? MySQL D group. There you need to under that you need to make the changes. Here also you can have your own config with the .cnf under /etc/MySQL location. You can have it. Okay. So we here why we are updating here is we might have the include directory in the my.cnf. I will show you. So here the parameters are server ID should be different. So we are making 200 and we need to enable the login. Login is we can name MariaDB source and then yeah, server ID login, then GTID domain ID. So this is we need to provide. Let's say we can give uh, 300 and GTID strict mode equal to on. Okay. I think that's it. Server ID, GTID domain ID, GTID strict mode, and we are also enabling the binary log. Yeah, fine. Let me copy this and saving this file. So here you can see why we are making the changes there inside the /etc MySQL my.cnf. By default, you will not have the MySQL D group, okay, by default, but you will see this include directory at the end. So there, this configs or these directories are included, right? So if in inside these two directories, if any file with .cnf extension, that will be also considered as a config. If you just want to use the /etc MySQL my.cnf, you can make all the parameters entry here with the proper group, and you can remove this include directory. Then you can just use your default file. Okay, but by with the default installation, with these configs are available here. So I just made the entry over there. That's it. Okay. Because I see some command why we are editing the this file and why not making the changes in the my.cnf. So I just wanted to tell that in this video. Okay, fine. Here service MariaDB restart, and here also let me make the same changes. Maria MariaDB config and 50 server.cnf, and here also let's make the update here. So here we need to change the server ID. I'm changing from 200 to 201, and GTID domain ID also I'm changing 300 to 400 here, and login MariaDB replica. Yeah, let me enable the log slave updates also here. This is not needed until you are having any replica under this replica. We already have one video explaining this parameter. Let me enable here in case if needed. Okay, if we decode bin log to understand some transaction, I'm just enabling it. But yeah, this is not needed for the replication. Okay, in case you are configuring the replication from the slave. For example, A is source, B is replica, and you want to bring the another server which is C under the B. I mean, B is already replica, but that is also going to be the source for the C. In that case, if you want all the data from A to C, then you need to enable the log slave updates in the B. Okay. Yeah, you can check my channel to understand this parameter better. We have the demo thing for this logly updates. Fine. So we made this different. No. Okay. Yeah. Yeah. So we just, yeah, it is here. Now let me restart the MariaDB service. MariaDB restart. Fine. So now we did enable the parameters and we restarted almost all the four MySQL and MariaDB services. Now let me log in and here show global variables like within wildcard GTID. Let's see. So here now you can see this GTID mode is on and enforced GTID consistency is on, and the same thing here as well. And here you can see this GTID domain ID is set to 300 and here it is 400, right? Uh, Let me do one thing. Just ignore show binary logs like reset master reset slave. So this is previously what I did testing. It was from there. So I'm just skipping that. That's it. Uh, okay, show slave status. This seems, let me see. So currently our show variables like GTID, right? Our GTID domain ID is we changed to 400 and this current position is something different. So yeah, so why, let me give some overview. So previously, I mean the before the session, I was tested here. That time I had the GTD domain ID 200. I'm not sure we did restart and I also flashed the binary logs, everything. Why it is still there, I'm not sure. Let me check. Okay, maybe varlib MySQL MariaDB bin MariaDB replica index. We have this bin log and show bin log also showing the same. I am not sure still why it is there. Let me check. Service MyDB stop. Let's funnel.ph grep -i bin and let me move this things. I need to decode later. I'm just moving it to temp. It is not needed anyway because we changed the bin log name to MariaDB replica, right? So now let me try to restart again. But yeah, still this is weird. I will check that later. Let me check now. Sh- Um, Show variables like GTID. Oh, still it is there. Let me check if any information from error log. I should conduct live session so that I will get some ideas. I am pretty much not sure why still we have this. We have this current position is also updated. And let me check the master status. Okay, so we have two binary logs. Fine. Was binary logs 2. We changed the domain ID to 400, but still why this reset slave all? Because we have this GTID slave position is also updated, right? Okay, reset master. This is interesting to debug. Anyways, let's try here. Uh, create database 3. So it might be incremented with the 1 and 1, right? Show binary logs. It will be generated the binary log and reset master. Yeah, it reset the values. But why it is not happening here? GTID current position and GTID slave position. Show slave status. Again, let me check if anything in the error log. Relay log info, master info, everything is deleted and recreated. But still, maybe a bug, I am not sure. What could be the reason? 10.3.39. Let me think. Not sure. Okay, so yeah, this is also increasing the time for the video. I will debug this anyway. This is quite interesting. So I will debug this after the session and I will get back if I find anything interesting on here. Because the behavior is it should reset when we run the reset master and reset slave, but I'm not sure why we still have this entry. Let me try to create the new session and check. Yeah, but yeah, if you have some idea on this issue, I would really appreciate this. Still, why we have this GTID strict mode is also on, right? And we set the GTID domain ID to different. Okay, let me check the table. Uh, select star from. Yeah, so I got it. So we have this entry here, but I'm not sure. It should be updated when I reset the slave, right? Uh, this is quite, maybe I need to check the bug related thing also. Fine. So at least I got this. So these entries are still there from my previous setup. So this this is still showing in the there. So let me truncate, but truncate is not recommended on this table. We cannot make any entry manually. For this is anyway we are testing the things, right? TRUN. Yeah, truncate table. I just truncated. So yeah, this is very like you should not truncate this table in your production. You will be messed up with the GTIDs. Okay. So my expectation is it should be reset when I am doing the reset slave, but it is not. I'm not sure. I need to confirm whether that is the behavior or I'm not sure. I need to check on that. Maybe this is bug or which is already reported or this is the expected behavior. I need to check for that. Okay, so for now, we can leave this as it is. In case you have any idea on that, just let me know. So Yeah, now I think it should be empty. Let me check the show variables like GTID. Yeah, so this two, yeah, now let me try to execute reset master and reset slave. Here, and let me check this. It is still there, man. Show tables, select start from. Let me restart once also. Show variables like GTID. Fine. So it is updated now. It needs the restart after I truncate the MySQL .gtid slave post table. Okay, but that is never recommended on doing the truncate directly. And also my expectation is it should be removed when I reset the slave. Let me check. And in case if you have some idea, please let me know. Okay. And yeah, maybe if you are new to this GTD in MariaDB, what I did for last 5 to 10 minutes, you may get confused. So I'm sorry for that. Yeah, fine. So now let's begin from here. So here you can see uh, our GTD domain ID we set, which is 300, and we can see that, and strict mode is also on, and the other node is also after a lot of struggles, you can see the GTD domain ID is 400, and you can see this GTD strict mode is on. Fine. So we can see this GTID mode is now enabled on both MySQL and MariaDB, and you can also see the difference in the parameter itself. Here we have the GTID mode and the enforced GTID consistency, and here you can see the GTID domain ID, which we set, and GTID strict mode, that is equivalent to enforced GTID consistency in the MySQL. Fine. So now what I'm going to do here is let's create a let's write the database. Let's create some transaction, and we will see how this GTID is generated and how it is incrementing. Okay, let's do in the MySQL first. Create database tree. So the database tree is created, and here you can see now show global variables like GTID. You can see this GTID executed is generated now, and you can see the structure, which is the UUID, and you can see one. Okay, UUID means that is the server UUID. Select at that server UUID. Okay, the same value is updated here, and this is 1 now, right? Now use 3, and let me create one table. Create table T1 ID int primary key. Okay. Now you can see this show global variables like GTD, which is incremented to 2, 1 to 2, which means it is starting from 1 and the next one is 2. And insert into T1 values 1. Now let's check the GTID. You can see it is 1, 2, 3, right? So you can see the server UUID is there. We see that in MySQL, the GTID structure is server UUID with the transaction ID, right? Which is incrementing when we create the database, which is 1. And when I do the create table, then it is 2. And now once I did the insert, it is 3. And if I do the another insert, it should be 4, 1 to 4, right? So it will be whenever the transaction happens with the UID, it will be increase. Okay. And this is the GTID executed. That will hold the executed transaction ID with the combination of server UID. Okay. GTID executed will tell you, oh, the until this transaction which are executed. Okay. Now we have one more thing here, which is GTID purged. Okay. So how we can understand this is show binary logs. So we executed the create database, create table, and few inserts that everything is stored in this binary log, right? Now let me flush the binary log. So it will close the old one and it will create the new binary log, right? Here. And this first binary log is contains all the transactions which we executed now. Those inserts, create database, and the create table, right? Now let me purge that bin log, purge binary logs to until 2, the bin log will be purged. So we have only one bin log now, and this bin log is purged. So this bin log holds the rights that create database, create table, inserts, everything, which was holded by that one first bin log, right? But we purged that bin log, right? Now let's check the GTID. You can see GTID purged is now updated with until 4. Okay. Now let's do one more insert to understand this better. I am doing 3 and 4. So I written two transactions, and you can see this GTID executed is now incremented from 4 to 6, right? And GTID purged is still on 4. So what it means, um, show binary log. So this fifth and sixth transactions are available in this bin log, right? Until fourth transaction, the bin logs are purged. 1, 2, 3, 4. These four transactions are written in the bin log 001. 001. We purged that bin log. We purged that bin log. So currently we have only 002, right? So once we purge that bin log contains the four transactions. So once the bin log is purged, and now this 1 to 4 GTD is also purged, because GTD is in the bin log, we purged the bin log, so it will update the status. And currently, our executed status is we have 6 transactions overall. From the 6 transaction, 4 transactions are purged when we purge the first bin log, and 5 and 6, those two transactions are available in the second bin log. So if I purge this second bin log, then it will also go away. For example, let me flush binary logs and let me purge the bin log from 3. So it might create the third bin log. Now I purge this bin log. Now if you check the status, you can see this purge is now updated to 6. Show binary logs. You will have the new bin log, which is 3. And when you made one more insert, what happened? That executed will be incremented from 6 to 7, and this purges still exists 1 to 6. What it means? Overall 7 transactions. From the seven transactions, 6 transactions are purged. Only that 7th transaction is available in the third bin log. Okay. So from this GTID executed, you can make sure until these transactions, the binary logs are not available. Okay, you can make sure on that, and the GTID executed will tell you how much transactions are processed now, and the structure is this UUID, server UUID colon the transaction number. Okay, so this is about the MySQL. Then we have the retrieved GTID executed GTID that we will see once we configure the replication. Now coming back to the MariaDB. So here, create database 3 logs. Now let's check this variable. You can see this current position and the bin log state and the bin log position. Everything is currently showing this one. So 300 is the domain ID. So we see the MariaDB binlog structure, right? First one is the GTID domain ID that you can see here. GTID domain ID we set to 300. So that is the first what how to say first column, the first set, and the next one is the server ID that is 200 we set, and this is the transaction sequence number, transaction number, which is the one. Now let's say inside the usery logs, and here if I create table t1 id int primary key. Now let's check the GTID. Now you can see this is incremented from 1 to 2, right? 1 to 2. And if I make some more trans writes, insert into t1 values 1, and if you see now, which is you can see this is incremented to 3, and if I insert one more row, and if you will see here 4, right? So this is the structure in the MariaDB. It is the combination of GTID domain ID and then the server ID and finally the transaction number. Here server UID and the transaction number. Okay, so here GTID current position will show you different number. I will show you once we configure the replication. I will tell the difference here. That would be easy to understand the thing. Fine. Yeah, so this is the basic like how to enable the GTD on both MySQL and MariaDB and the structure of the GTD. Now let's set up the replication on this both MySQL and MariaDB. So here we just need, I already created the user. Okay. So I will use the same user, and this is the host name, right? And in the binlog based replication, what we will do, we will provide the master underscore log underscore file, source underscore log underscore file, and the source underscore log underscore position, so that from that position the replication will start, and the further events from that position will be replicated to the replica, right? So here we need to give the master host, that is the your source IP, and the user this is already created, and this is the password, this is also already created. And instead of the master log file and master log position, or source log file or source log position, you need to provide the master auto position or source auto position equal to 1. Okay, it will automatically get the GTD until which it is executed, it will apply the thing. Okay, and here, yeah, this get master public key, that is for this latest 8, we have the catching plugin, right? So it needs the public key access. So we are setting that to 1. So instead of master log file and master log position, we are just giving the master auto position equal to 1. That's it. We don't need to give the master log file and master log position here. Okay. Now, let me set up the replication. It might be failed because we already deleted the bin log for which contains the database, uh, like create database creatable, right? But this latest bin log will have the insert statement, so it should fail. So let me reset master here, and yeah. So now start slave and show slave status. Yeah. So now you can see this IO and SQL both are running. Fine. And coming to the MariaDB replication setup, we have show binary logs. Okay, show Show binary logs. Okay, we have the binary logs available here. And here change master to master host, master user, master password. This master user password and host are mandatory for the binlog based and the GTID based, because we need to tell the replica to where to connect, and it need the credentials to authenticate the master, right? Your IO thread. So this is mandatory, but instead of master log file and master log position, we are skipping that. Instead of that, we are using the master auto position. And here, master use GTID equal to slave position. It will automatically get the ID and it will start to replicate. So for example, let me run this command on the MariaDB slave and start slave, show slave status. Let me check. Yeah, so here you can see IO thread and SQL thread both are executed. Fine. So we just configure the replication. Now we need to understand few more things, few more configs. Okay, few more parameters of this GTD, and that will be really helpful in case of your replication got broken. You need to identify it until how much it is executed and how much it is not executed. So yeah, let's see about it. For example, if you check this, let me create database reblogs here as well. Fine. And on the MySQL master, use reblogs and create table T1 ID int primary and insert into T1 values 1 and 2, 3, 4, 5. Okay. And now you can see use three logs on the replica. Select star from T1. You, uh, you can see the data which is replicated. Fine. Show slave status or show replica status. You can see these two columns, which is retrieved GTID set and the executed GTID set, right? And if you see here, show global variables like within the wildcard GTID, you can see here, this is also same. GTID executed is also same, and retrieved GTID set also same. Executed GTID set is also same. Fine. Now you may have some replication error or somehow your replication SQL thread is stopped. So let me stop it manually here. Stop slave SQL thread. Okay, which means I just stopped the SQL thread. I just stopped the SQL thread. Your IO thread is still running. So it will still read the bin logs from your master, but it is not going to apply on your replica because I just stopped the SQL thread. Okay. Now let's see. I'm writing one statement. Two statements. I'm writing two statements. And you can see this GTID executed is increased from 7 to 9. And if you check the slave status, you can see now the retrieved GTID set is 1 to 9, but the executed GTID set is 1 to 7, right? So the reason is now, yeah, now you may understand what is the difference between the retrieved and executed GTID set, right? So retrieved GTID is something how much until which GTID position the IO thread read from the master, and it is stored in the relay log of the slave. Executed GTID set is until which GTID transaction is applied using the SQL thread on the replica. Okay, in simply, I would say retrieve GTID set is related to your IO thread, and executed GTID set is related to your SQL thread on your replication. So now start slave MySQL thread. Once you started your slave, uh, now you will see the pending two events are applied from the relay log. Now you can see both are same, right? You can see this IO and SQL thread both are running. Fine. So this is the difference between retrieved GTID set and the executed GTID set. And sometimes you may see, for example, show global variables like GTID. On the slave I am doing, you are seeing this GTID executed is currently from the master. This UUID is from the master, right? This you can see this 5DF23, 5DF23. This is from the master 1 to 9. Sometimes you see this GTID executed with the different combinations, different sets, right? That how you will get it. For example, create database 3 logs 1. Okay. Now, if you see your GTID status, your GTID executed currently have two sets, right? So you may actually I had one of my friend asked to me, I am seeing lot of sets in the GTID executed, how it can. Then I was checking, they had the cluster thing, group replication he had, and so there it might, and they are also writing on the different nodes, so it should generate at the different sets. Okay, so to understand that better, so previously we had only this set. This is from the master. This UUID from is from the master, and this UUID is from the replica. For example, select at server UUID. Okay, and you can see this is C8, right? C8, 8D C8. So this is from the replica. So when you are so previously this is only your replica just receive the writes from your master. So you just keep the GTID executed from the events which are executed in the replica from the master. From this ID, from this UID, these transactions are executed. That's it. But now we also written on the slave. We created one database. We created the database directly on the slave, right? So when I am writing, it cannot interfere. I mean, it cannot conflict with this existing one because this is unique. This is from the master. So whenever I am writing in the master, then this set will be updated. But here I am also, when I am writing in the slave, let's say consider master replication, you are writing both way, otherwise group replication, you are doing the multi-source, you are writing on all the nodes, or even the InnoDB cluster, you are writing on all the nodes, multi-primary thing. Okay, there, when you are writing on the different nodes, then each node will create their own set of GTID, right? That's what I'm coming to say here. So when I'm writing in the replica, it creates its own set, GTD set, with the replica's UUID and the replica's transaction number. For example, Sri blocks 1 create table T1 ID int primary key. Now let's check the GTID thing. Now you can see this is 1 to 2 now. And whenever I am writing, it will be increase on this counter, on this set. It will not interfere with this set. Okay. So you may have lot of sets, depends on your nodes and how many nodes you are writing and how they are connected, right? Because see, now I just written on the slave, but this slave, whenever I'm writing on the slave, it is not going to replicate on your master. So it will not impact your master. Your master will still have the its own GTID set. But when I'm writing on the master, it will replicate to slave. So we have these two sets, master sets and slave sets here. Okay. So this is completely depends on how much nodes you have and how they are connected and how much nodes you are writing. Okay, fine. So this is understandable, right? So in this slave, I have two sets, and one is when I'm writing on the slaves, and it will increment on the slaves GTD set, and when I am writing on the master, it will be incremented through the master. So just for the example, I am writing on the slave. Okay, but writing on the slave is not recommended to maintain the data consistency. This is just to show how that we have the different sets. And whenever you have the replication error or the thing, you just need to check that particular set which is creating the problem, and you need to focus and debug based on that particular set only. You don't need to confused with lot of sets. Why we have lot of sets, or maybe everything is impacted. Nothing like that. Okay. Fine. So yeah, so we did see the configuration of slave, and we try to understand the retrieved and executed GTID set. And this is one more scenario when you have the different GTID sets on the GTID executed value parameter. Okay, so this is for MySQL. Let's keep it. And now let's move to the MariaDB side. So here also, now let's try to write something. Use three logs, select star from T1. Okay, we already have some rights. And here show variables like GTID. You can see this is 4 because we created the database and created the table and we made 2 inserts. So overall 4, you can see the 4 here. And here also you can see, here we do not have the retrieved GTD set or executed GTD set. Okay. But here you have the directly GTD IO position, until which IO position we have, which is 4. And here also you can see 4. But how to know the executed GTID set? So this is, you can consider as a retrieved GTID set. GTID IO position is equivalent to the retrieved GTID set. But how to understand the executed GTID set? That you can understand from, let me show global variables like GTID. Okay, so here you will see GTID slave position. Okay, so for example, let me do the same thing here. Stop slave SQL thread. Okay, so which means show slave status. My replication, only the SQL thread is now stopped. Now let me write on the master just an insert 3, 4, 5, and yeah, 2 more, 6 and 7. So I created 5 inserts. Now you can see the GTD, which is now 9, from 4 to 9, because we did the 5 transaction, 5 insert, right? And here you can see show slave status. You can see GTD IO position is 9, as same as a master, because my IO thread is running. But so this what I tell, this GTID IO position and the retrieved GTID set on the MySQL and GTID IO position from the MariaDB, both are same. Now let me do the show global variables GTID. You can see this GTID slave position, which is still 4. Okay, this is still 4. This is you can consider as a executed GTID. GTID slave position variable is equivalent to the executed GTID set on the MySQL. Okay, now when I resume the start slave SQL thread, when I resume the replication, you see this GTID slave position is updated. Okay, fine. Now the same as this GTID executed, we had 2 sets here, right? Now, sorry, let me try to write on the slave. Let's create database 3 logs 2. Okay, now let's see this. Yeah, So GTID current position, you can see this is the like the same kind of the set you see here. That is now here also you can see comma separated. This is the first set and this is the second set, right? And this is from the 300. 300 is the master's domain ID, and 200 is the master server ID, and this 9 is the current transaction number from the master. And here you can see 400, which is the slave's domain ID. When you are directly writing on the slave, it will generate it with the slave's domain ID, and 201 is the slave's server ID. And we created only one create database statement, and you can see one. Okay, and here if you see create table T1 ID int primary key. Now let's check. You can see this is incremented to 2. Okay. So here we differentiate the servers based on the UU server UUID. In the MariaDB, we can differentiate the servers based on the GTID domain ID plus server ID. Okay, some people's do configure the GTID domain ID is same and server ID is different. So that is also I can see few of the people's doing. So you need to differentiate by the combination of GTID domain ID and the server ID. Okay, you got it right. Now, yeah. So what else? Yeah. So now, fine. So replication is running on both this nodes, show slave status. Yeah, here also running and here also replication is running fine. So now let's do one thing. We will create one duplicate entry error, and we will see whether how we can fix it. Uh, on both, there is a different in the MySQL and MariaDB. Let's see how to fix that. Okay, and yeah. So yeah, one more thing I want to explain for this last GTID column. So this is actually the session variable. So it will have the last executed transaction on the same session. For example, here let me make one more insert 8. You will see this is now updated to 10. I mean, same as a current position, it is 10. Now let me quiet this connection and let me reconnect. And if you see this last GTID, now it is empty. Okay, so that will just tell you once you return on the session, then what is the last executed GTID. That will be explained here. Okay, and yeah, for example, now insert it into 9. Sorry, Sri vlogs, right? Or Sri. Okay. Use Sri vlogs. Yeah, 9. And now if you see the yeah GTID, last GTID, now it is updated. Okay, so when you are writing on your session, then only this last GTID will be updated. Otherwise, when you are freshly connecting the session, then it should be empty. When you are freshly connected, it will be empty. When you started writing, then only it will be updated. Okay, fine. And yeah, let's do this thing. Show slave status. You can see this IO and SQL both are updated. And here also it should be updated. Fine. Now uh, use Sri vlogs, select star from T1, and here also use Sri vlogs, select star from T1, 7 and 7. Now let me create one duplicate entry here. I am writing on the slave insert into T1 values 8. Okay. So this is in create this value is created on the slave. Now let me create on the master. This 8 ID column is the primary key, right? So it will not allow the duplicate value. So when I already created this 8 this insert on the slave, then I created on the master. So when I'm doing this, this insert will try to execute in the replica and it will create the conflict and it should break the replication. Okay. So here you can see we have the last SQL error. So we have this multi-threaded replication. So you can check the exact error detail from this table that is reported in the error log itself. Sorry, error itself. This table you can view it. Okay, select star from this. So we have 4 workers by default. So you have the 4 rows. Yeah, exact error is with the first worker. You can see this could not execute right row event duplicate entry for the ID value 8. Okay, so we are aware of this duplicate. So I just decided to skip it. Okay, skipping again, I would say, I think I tell many times, skipping the error is not a solution for all time. So in case if you are doing skip, you need to make sure your data is consistent by running the checksum to ensure the data consistency. Okay. So here we already have so for the task perspective, we are just skipping this. Fine. So this is the error. Now let's compare with MariaDB. I am doing the same in the so in the MySQL side we already created the error, and in MariaDB select star from T1 we have 8. Okay, not sure why this star is. Yeah, we have 9 values already. Here Srivlog select star from T1. Here also we have 9. The same way, insert into T1 values 10. On the replica, I created this record in replica first. Then I am going to create on the source. It should create the replication error because we are aware that ID column is the primary key. So this 10 after creating on slave, when I'm creating in the master, it will try to update the value here, but this value is already exist. 10 is already exist, so it should create the duplicate entry error. Fine. So this is mostly same error. You can see this is also duplicate entry for the value 8 and here also duplicate entry for the value 10. We have the error is same on the both MySQL and MariaDB we created. So usually, yeah, let's skip this thing like we already verified the bin log position and bin log events, and we also verified that YD value for the all the columns are same or not. And finally, after investigate all these things, we decided to skip these values. So we made sure with the skipping this parameter will not impact anything. So this is the redundant thing. We already have this value in data in my table. So that is consistent with master. So I am just wanted to skip this error. That is the thing. I decided to skip the error. So yeah, regarding again, the skipping is not a solution all time. It will silently make your data inconsistent. Okay. So we have few videos, I think 2 to 3 videos in our channel, like how to approach this kind of errors, how to decode the bin log, how to analyze the events, how to fix the replication error without losing the data, and how to make the checksum and sync. These all videos we have in our channel. can go through it. So after this all the analysis, we are decided to skip this event here in this situation. So this is, I also made sure this is the only insert I need to skip. There are not much transactions to skip. Only this insert statement needs to be skipped. Then usually what we do in the binlog based replication, set first we will stop the slave, stop slave, then set global SQL slave skip counter equal to 1, right? To skip the one event, we will do 1. Then we will start the slave. So when I am doing this with the GTID replication, it works. It works well in the MariaDB. In MariaDB, it is working. Let me come to the MySQL side. Stop slave, set global SQL slave skip counter equal to 1, start slave. So if you see here, 1 second. Yeah, so sorry. Now let's check the status. Show slave status. If you see, my error is still exist. The SQL thread is not fixed yet. So with MariaDB, when I for the same duplicate entry error, I am able to skip with skip slave counter. But on the MySQL with the GTID replication, I am not able to do that. With MariaDB GTID, it is skip slave counter is working, but for MySQL, this is not working, right? The for the MySQL GTID replication, slave skip counter should not work. So then how to fix this error? That is the next thing. So if you running the MySQL Percona server with GTID thing, then let me show you. So we already decided that that transaction is not needed. Anyway, we are not going to skip it, right? So here you can see this transaction is from this bin log and this position, and we can also make sure about this transaction using the GTID thing. So my retrieved GTID set is 10. My retrieved GTID set is 10. You can ignore this. This is my slaves. We made some writes on the slave, right? This even, so this set is from my slave. So you can ignore this from the executed GTID set. I need to focus on this GTID set. So my retrieved GTID set is 10, but executed GTID set is 9. The 10th, the 10th transaction is creating the problem here. The 10th transaction is creating the 10th insert statement here, which is creating the duplicate entry. So I just need to skip this 10th transaction here, right? But setting the skip slave counter is not working because I am using the GTID replication, right? Then how to do that? You can manually inject the empty transaction for the 10th transaction ID, then you can resume the replication. Okay, and you can also skip by doing the another method like with the what is that, slave exec mode equal to item one, but that is not recommended. It will skip all the errors which you have. But you, yeah, if you have, make sure this is the only event, then you can go with that. But if you have a lot of replication error, then that will be creating again the problem. You need to check the consistency and sync all these things. Checksums are needed. Fine. I will show that as well. So here, how to do for one kind of event, you can just stop the replica, stop slave. Then you can, there is a one more value which is GTD next. Okay, there you can set the GTID from where to, from which GTID, which transaction number it needs to start, that you can set it up. Okay. So for example, set session GTID next value. In the bin log also, all the transaction entries will have the GTID next and that particular number. That's it. Okay. So here, if you see this inset, which is having the uh, uh, let me show from the bin log so that it will not get confused. So here you are aware of this error, and let's say this is the bin log, right? So this is the bin log, master's bin log. You can decode it where lib MySQL bin log base 64 output equal to decode rows and hyphen, I'm adding verbose, and this is my bin log file doing the less. So you are aware at this bin log, at this position, the error occurs. So you can, let me find that position here. And this is my position, right? And you can see the GTID next value for this position is this one, 10, which is the 10th transaction. Okay. So this is what I try to set it up here. So you can also see here from the 10 transaction, 9 transactions are executed. The 10th one is getting the failed. The 10th one is the insert statement to 3 blocks T1 and at the rate 1 means ID column 8. And for this transaction, the GTID next value is 10. Just copy it and you can manually set session GTID next equal to 10. That event which is creating the conflict, I am manually setting that in the session level, then begin commit. I am just manually committing that. So I set this GTD next value. So the next transaction will take this value. Okay, this 10th value. And the next transaction, what I did, I just did the empty transaction. So now this 10 is committed. Now this GTD next 10 value is committed. So got it, right? So for every transaction before that, we will have the, see this transaction is beginning here. But before that, we will have the GTD next value. It will be assigned for that transaction. Okay. So in our case, that insert is assigned. I mean, this for before this insert, which is creating the duplicate entry error. Before that, we have this GTD next value. That is the 10th transaction. And you can also make sure you can verify here in the executed GTD set and the retrieved GTD set. Retrieved GTD set is 10 and this executed GTD set is until 9. The 10th one is missing. Right. And you can also check the bin log and position and you can find the exact GTD next value as same as here. Before the transaction, I mean, before the begin statement, you will find the GTID next value. So this GTID next value is creating the problem. So what we are doing, we are just setting up for the GTID next in the session level, and we are just committing this value. We are just committing this value with begin and commit, which means it is the empty transaction for that 10 value. And once you did that, you also need to set session GTID next to automatic. Yeah, now it will be picked up by the automatic behavior. You don't need to set it up anything manually because we already committed the GTID next value with the empty transaction. Okay, now it will be rely on the automatic and just start the slave and now show slave status. Your IO thread and SQL thread both are running. And you can see this GTID executed is also 1 to 10, retrieved is also 1 to 10. Executed is how it is 1 to 10 because we manually set it to 10 and we manually committed this by the empty transaction. We just skipped this insert statement. We just skip that insert statement. We just copy the GTID next value for the relevant bin log file and position which created the error. We just set it up manually. And instead of this insert statement, because this statement is creating the error, so we just skip that insert statement and we just made the empty commit, just begin and commit. So now this is committed, and then we started the slave. Then it will start the further positions, and you can see this executed value is also updated here. Now the further transactions, anything you write here, let's say if you write 9 here, it will be works automatically. Executed is 11 and retrieved is also 11, and select star from T1, you have the 9, no issues. Okay, so this is the method. You can manually set up the GTD next value and skip it. Okay, and you can, yeah, one more thing. Let me create one more duplicate entry error with the insert statement. Yeah, insert. Now the latest value is 9, right? So I'm just making 10. And now let me do this insert on here 10. Anyway, it should create the replication error. Show slave status. It should create the duplicate entry error, the same error. So we know that skip slave counter should not work. So we see how to fix that by injecting that empty transaction. And one more method, you can skip it using set global slave exec mode equal to idempotent start slave, and if you see the show slave status, those errors will be skipped. And once you did that, you need to make sure you need to make it too strict. But this needs to be taken care very carefully, because setting the idempotent slave exec mode equal to idempotent will skip all the replication errors. All the replication errors which have the duplicate entry and the update error key error. Both these errors will be skipped. How many duplicate entry you have, every errors will be skipped, and how many update row events you have, those all the errors will also get skipped. So you need to be when setting up the item model, you need to be very clear on that how many transactions you need to enable some verbose output to capture the errors. And whenever you are doing, if that is you already analyze everything properly and this is the only statement you want to skip with the GTID, you can go with that approach what we see first, and you can also go with this, but you need to be make sure what is happening in the background. And also when you are doing this, it is I would strongly recommend to run the checksum because you already so yeah, here we created this error purposefully, but in your production environment, if you are having something like that, it is recommended to check the other data as well to ensure the consistency. So it is recommended to have the checksum run, and in case of any conflicts, you should sync the data as well. Okay, fine. So we see that skip counter is working on the MariaDB. On MySQL, it is not working, right? Fine. So today we see that basic structure difference between MySQL and MariaDB, and the configuration difference between MySQL and MariaDB, and this replication setup, and this retrieved GTID set and executed GTID set, the equivalent value on MariaDB, and the skip thing also we see finally. So as I mentioned first, this is the part one video. I will come up with more on the GTID comparing to MySQL and MariaDB in the coming days, and I also have the plan to create one video about this enforced GTID consistency parameter. So yeah, will be come up. So yeah, again, the same thing. If you are like this video, please subscribe my channel and share with your friends. And I'm also taking the course for the MySQL DBA. In case if anyone required, you can reach me. Thank you very much. Bye.